We started with this, a polynomial, and we need to factor out a monomial. So what we started yesterday by breaking it down into the prime factorization. So we know this is 3 times 1 times x plus x. So the only thing that I can take for both pieces is my x. Times. Alright, so I can pull an x out, and then this stays the same. So 3 times 1 is 3x. We had our understood 1 in front of the x, so 3x plus 1. Now,
I got a question.
yes, ma'am.
Okay, you see how you put them 2 x's?
Alright, yes, I have 2 x's, because that makes x squared.
Right. No, I get it.
Alright, so let's look at one more problem from yesterday. Review. So we have 10x cubed minus 5x squared plus 25. Alright, 10x cubed minus 5x squared plus 25. So the first thing I want to do is see what I can factor out. So make it down into our prime factors. So this is 2 times 5 times x minus 1 times 5 x plus 5 times 5. Alright, so I'll go through. Here's a 5. There's a 5. There's a 5. That's the only thing that I can pull out of all 3 pieces. So I know it's 5. 2x cubed minus x squared plus 5.
I knew what I was going to ask you. Why you going to get that?
Okay, hold on. Time out.
You start with 3 5s, but you want to put 1 5. Like, why ain't the x on the 3 up there?
Because I took 5 out of each piece. So this tells me if I go back and use the distributive property, then I will get back to this. So all I'm doing, I'm taking out what I can distribute, can give back. If it's not in all 3 pieces, you can't take it out.
Okay, I get you.
All right. What's your question, Deja? All right, Ashley, what's yours? Mr. Lee.
What are all the prime numbers?
Right.
Like, I'm talking about between 1 and 10.
3.
2.
7.
2 is not prime nor composite.
3.
What 2?
1, 3, 7.
2 is 1 and 2 are special. Those are special.
3, 5, 7.
2. Wait a minute. 2 is a prime number. Let me go back. 0 and 1 are the special numbers. They're not prime, not composite. So 2, 3, 5, 7, 11. All right. That's exactly what I have. Didn't put it in the trash.
She put in the refrigerator.
No. All right. So today, we're moving on to what's called the difference of perfect squares. All right. So the difference of perfect squares will look like this. All right. Let's look at these 3 problems. All right. Problem number 1. Now, how do you know that the problem is showing you do a difference of perfect squares. First, you look at your number. 9. 9 is a perfect square because that's 3 times 3.
Yeah.
X squared is a perfect square because that's x times x.
Yeah.
And 1 is a perfect square because that's 1 times 1. So if all of your pieces you can take a square root of, then you have a difference of a perfect square. Now we know it's difference because it's got a subtraction sign. So perfect square, perfect square, perfect square. So we know we can do the difference of perfect squares. So what that means, you take the square root of the number, you have a parenthesis, and a parenthesis.
Yeah.
So 9 is 3 times 3. So you have a 3
Yeah.
and a 3.
So why you doing it like that? Why you doing like this? Yeah, why you doing it like that?
Now, because we're figuring out what two polynomials we can multiply back together to get this answer.
Oh, that's how we doing it. Oh,
Alright, so we're factoring them.
Coach home. Okay, so
Alright.
you know if you're gonna do it like that or the other one.
What do you mean?
Like, you know if you're gonna do it that way or the one you just did.
Okay, because we know this is a perfect square, this is a perfect square, and this is a perfect
So they're
square.
all gonna be perfect squares.
Yes.
Yeah.
All pieces have to be a perfect square. Alright, so we know x times x. Now, in order to get a negative sign, one number has to be positive and one has to be negative.
So you put a positive one in one and a negative one.
So a positive, one of them's positive, one of them's negative.
I think we did this before.
Yes,
No.
should have.
I know.
Not this year.
Not in this class.
No, not this class. You should have done it last year.
No, I didn't.
All right,
All right.
I'm lying.
All right, listen, quiet. So how do I get 1? 1 times 1. Now, listen. So at this point, you're finished. Now, how can we check it and make sure this is the correct answer? Justin,
Let's multiply.
not this, well, what did we do in our last unit?
Multiply.
Multiply. We're gonna
I
multiply.
said multiply. I was just like,
So 3x plus 1, 3x minus 1.
yeah. They're doing that again.
1 times 1 is 1, but it's a negative. Negative 1 times 3 is negative 3x. 3 times positive 1 is 3x. 3 times 3 is 9. X times x is x squared.
That's too much.
9x squared, that goes away, minus 1.
Okay.
And it got us back to where we started.
Exactly.
Now, so you have to check each piece and see if it's a perfect square. If all the pieces are perfect squares and it has a subtraction sign, you know it's the difference of perfect squares.
Okay, can we set it up like the other way though, too?
Can we do one like,
Like,
minus 5 or something?
Alright? So let's look at the next problem.
Yeah, like, that's easy.
Hold on.
Let's do something like minus 5 or something.
We're not to that kind yet, Tony. Alright, so let's look at this one. 4, is it a perfect square?
yeah.
N squares.
How do you know if it's a perfect square?
Because 2 times 2 is 4.
Yeah.
N times N is N squared. So you have to look and see.
It could be 7.
Yes. Alright, so is 49 a perfect square?
Yes.
Yes, so we have check, check, check. All of them are perfect squares, so we can move on.
So what if it's not?
We'll get to show you one in just a minute. Alright, So 4. How do I multiply to get 4?
2 times 2.
So you know you gotta have 2 times 2. How do I multiply to get n squared?
N times N.
N times n. We know one's positive, one's negative. Alright? How do I multiply to get 49?
7 times 7.
7. So 7 times 7. Alright? Then multiply it back together to make sure that you're correct. 2n plus 7, 2n minus 7. Negative 7 times positive 7, negative 49. Negative 7 times positive 2, negative 14n. 2 times 7 is positive 14n. 2 times 2 is 4. N times n squared. 4n squared. That goes away minus
49.
49. Is it back to where we started?
Yeah.
Yeah.
I answered your question that time.
Oh, I see how you're doing it. I did it wrong. Okay, then, so this is
Alright.
my question.
Now, let's look at this next problem.
So,
He still, you ask him to still do it like the first week, you know, it's positive square or whatever.
Alright, this is one that Tony's asking about. What in the world am I going to do? I have 180 m squared minus 5. So now, this is where we have to go back and look at what we did yesterday. Is there a number that I can factor out of 180 and 5? So I can just take 5 out of both of them. Woo! So 180 divided by 5. 3. 36. So now I have 5 times 36m squared. 5 divided by 5 is 1. Now do I have difference of perfect squares? Yes.
So where I messed up in?
You gotta keep 5 outside so you can do 5. Then you got 6 in both of them. And one of them will be plus 1, one of them will be minus 1. So your answer.
Positive, she didn't go 2 times 2.
Oh, you.
So this is taken away.
Um,
Alright. So, at this point, I'm not even looking at my 5. So is 36 a perfect square?
yeah.
Yes. So I have 6 and 6. M squared is M times M. That's a minus, so that means I have to have a positive and a negative 1.
Oh, no.
Now, what in the world do I do with my 5?
Put it on the outside.
Goes right there.
Told you.
There's your answer.
what you need?
So is this right for the script? Just do it like that?
Yeah.
Dang, jeez.
You pressing my head.
Alright, Miss Bill.
Oh, no,
At this point, you're finished.
Nah, jeez.
So that 5 just comes down and stays on the outside.
Answer your question.
Alright, let's look at it one more.
Okay.
I don't do that 1 piece of cake. So, 216. Number 9.
We're going to look at number 12.
Look at number 9.
You want to see number 9?
Dang, y'all got all these big numbers. Man, you gotta think.
Alright.
Oh, numbers. These are good numbers. I didn't know.
Alright, let's look at this one first.
Oh, you're so.
I have 24x cubed minus 54x. Alright, so now I'm thinking, oh, I don't know.
Take six.
Just factor 6 out of both.
Take six.
So I can factor 6.
Yep.
I know that this is 24 is 2 times 12, which is 3 times 4, so that's 2 times 2. Right?
No, it's,
6.
it's 2 times 2 times
3.
Yeah.
2 times 2 times 2 times
2 times 3 is 6. 6 times 4.
2 times. So it's 2 times 2. It's
You
2
got it right.
times 2 times 3.
Yep, we got it.
There you go.
Times x, times x, times x. Alright, minus. We gotta see if there's, because 24 is not a perfect square. So I have to go back one step and see if I can factor something else. Alright, so 54 is 6 times 9, which is 2 times 3 is 6, 9 is 3 times 3 times x. Alright, so I have a 2 and a 2, I have a 3 and a 3, I have an x and an x. So 2 times 3 is 6, so I have 6x. Now, 2 times 3 is 6. Nope, 2 times 2 is 4. X squared minus 9. I said 2 times 3, but I already took 3 out. Alright. So now,
You making it hard now.
so we're going to have to use yesterday's lesson with factoring and today's lesson with difference of perfect squares. Alright, so how do I multiply to get 4?
2 times 2.
2 times
We're not done.
How do I multiply to get x squared?
2x times x.
X, x. How do I multiply to get 9?
Plus 3 minus
So a plus 3
3.
and a minus 3. Now, so I have to bring my 6x down.
You recorded me too.
What the clinic said me?
I must be out.
Papa said, what's the
Alright, no, back there on the table. Alright. Any questions?
Why? Gonna do number 9.
Go ahead.
What is pushing up to
Hold on, we got somebody confused.
Yeah, nah, I'm good.
You figured it?
I thought it was some more. I tried to do some extra stuff at the end. too.
Oh, I see. Alright, let's look at the next one.
Yes, but it still turns out to be 6. So, like, why did we go through all the factors? It's still 6.
You don't even know.
Because you said.
You have to take it to the prime factors to see what you can take out. Alright, so I have 150 and 216. Alright, we know they can both be divided by 2.
Yeah.
Because they're both even.
Which would be 1.
So 150,
75 and 108.
alright, 2 times 75. How do we get 75?
Times 75 divided by 2, 35.
5
You can't
times
divide
5
5
times 3.
by 2.
Because 75 is 3/4, right?
Yeah.
So 3
Oh.
times 25, and 25 is 5 times 5.
I forgot about 25.
Alright. Alright, so let's look at the next one. Minus 216, so we know that's 2 times 108. 108 can be divided by 2, because it's even.
54.
2 times 54,
Then divided by that.
Man.
Equals
56
6.
times 9. So we're at 6. How do I get-
Times 3 times 3 times 3.
6 is 2 times 3. 9 is 3 times 3. Alright. So let's look and see what can I pull out.
2, 3,
I can have a 2.
3,
I have a 3.
4, 5,
Alright, so 2 times 3 is 6.
No, it is.
5 times 5 is 25. K squared minus 2 times 2 is 4. Times 9 is,
Oh my God.
36. Yeah, 36.
alright,
Now you got it.
Wait.
alright, so are these 2 times 2 times 3 times 3?
You're not done.
Yeah, then you gotta do the factoring thing.
Yeah.
So
Now
that's
you got that 6 on the outside.
Hold on,
5K
come out,
plus
come out,
6, 5K.
hold on. Alright, Ms. Johnson,
Oh.
I pulled a 2 and a 3 out.
Oh, okay.
So here I multiplied
So you,
2 times 2 times 3 times 3, because that's what was left.
so you do that first. You add all that together first, and then subtract that by whatever you get. So that's how that. Ah,
Or you multiply.
yeah.
Alright, so now, I have 6, what's 25?
5 times 5.
I said the answer already.
So we know we have 5 and 5, k squared is
5K plus.
k, plus and minus, excuse me. 36 is 6 times 6.
Hold on, you love me.
When is the homework due?
Alright,
Okay. Alright, let me do it tomorrow.
does anybody see? Alright, I'm gonna stop recording here.
Hold on, try.
22 minutes.